Hello, my name is Mohamed, computer engineering. We're doing the EECS lab 1011 lab 2.
This is Nadir Shah, and I'm in mechanical engineering and field doing lab 2 circuit world.
Oh, yeah. So what are the alligator clips? Is it? Pardon? I don't think so. I think it's pretty easy to do without. I just don't know which one's which now, which goes to which. Oh, right, there we go. Okay, so. Yeah, you want to check the menu and make sure it's good?
This one's 10.5, so this one. So now we're finding the second resistor with the same amount of ohms.
The problem is I can't fix it.
9.95. So give or take, this is the same resistor because it has almost the same resistance. Resistors into one load as a series.
We'll do an introduction video, so we'll be like, okay, I'll say my name, you'll say your name, we'll say the program we're in, and then we'll be like, say the class, and then we'll say that this is lab number 2. What's the lab called, actually?
Let's do that one last, in case we have time.
Okay, yeah, for sure.
Because like, that's how you know time.
Okay, let me just get this. We're doing like 1 second.
Okay.
Make sure this.
So now we have connected both. I think I can like zoom or some shit.
No, you zoom from there. Yeah, the plus, yeah.
Alright, so for the first part of the lab, we are going to be testing these resistors to try and get 10K ohm resistor.
Okay, so now as you can see now the resistor is now equal to 3 of our identical resistors, and we are getting resistance of 3, which means that now since there are 3 resistors, the resistance should be 3. There you go. Now we will measure the resistance. So now, as you can see, this is 40k ohms found in all 4 resistors that are connected in a series circuit. Okay, so now we will be using MATLAB to plot our the load resistance versus the number of resistors in the load. So our x values will be the number of resistors. So there were 4 of them. So we'll go from 1 to 4.
And then we are going to get 4.
Okay. And now since our load resistance was from 10 to 40, we will put go from 10 to 40 with an increment of 10.
Value is 39.4. So as you can see, as each 10K ohm resistor you add in series.
So now that's 10, 20, 30, 40. So now we should be able to plot this by using plot x by y. And MATLAB should be doing its magic. Never mind. No, it worked.
Oh, it's a warning. I thought it was an error.
Oh, that's fine. So as you can see, from 1 to 10, 2 to 20, 3 to 30, 4 to 40. So that now makes sense. So now since we have shown the graph that is for just for the 4 identical resistors, now we will show the graph for n identical resistors. So as many as the resistors were, the graph will be shown. So with this, we'll first give a value, an example value for n to show as an example. So now our x value will go from 1 to n.
Oh, measure 1.
Yeah, not 2.
So like this.
We went to n, and now we will make our y value 10x. 10 multiplied by x. So to
Any questions?
no, I'm good.
Yeah, they're really good help.
So and then from there, then you can plot the graph.
But they help. They help.
So plot.
I know. Okay, so should we record this? Yeah, I recorded. I gotta start over. Right? Do everything.
It takes some time.
It comes.
Okay. So now as you can see, the one register to 10 is the same, 2 to 20, 2 to 30, 4 to 40, and now the n, which are the new values that it has calculated to 5 to 50, 6 to 60, 7 to 70, and then so on. It will move.
So to avoid using a wire, we're just gonna.
So now our goal is to connect two resistors into parallel onto the board. So now we are checking the resistance, and it is coming out to 0.5. So 50. Yeah. Next part, to connect three identical resistors in parallel. We have connected three of them here, and now we will measure the resistance on all three of them, which it comes out as 33. So that means the more resistors we add in parallel, the lesser the total resistance becomes. Going to plot the number of resistors in the parallel sequence against the load resistance. So since there were three of them, we will go from 1 to 3. Okay, and then so that's 1 to 3. And now since the resistance in total went down from 10 by the number of resistors attached, so it means that was 10 divided by the number of resistors. So we have that. Now we'll plot both of these together. So as you can see, as when there was only one resistor, the total was 10. As it went to 2, it went to 5. So and it went to 3, it was at 3.3. So it makes sense for it to be a bit above. Okay. And now to make the graph to be extrapolated to n identical resistors, we will change the x value. We will first give a value to n for that. So then we can change the value for x. So it'll go from 1 to n. 1 to n. So that's 1, 2, 3, 4, 5, 6, 7. So from there, the y should now be 10.
But I just want to make sure this, does this make sense?
Since the y it does not change, we can leave that as that. Now we will plot x and y.
It's 3.30. That's why I want to ask him to see if it makes sense. Just to double check.
Like, yeah, that does, because, like, one resistance is like 10, right?
Yep.
So, like, 2 is like half that, and then 3 is a third of that.
Oh, that's how it should be? Oh,
Makes
perfect.
sense.
No, that makes sense. That makes sense. I'll even state that.
So as you can see, the graph hasn't made. So as you know, it makes sense. So 3 for 4, it went even lower. 5, it should be at 0.25. So over there, yeah, it's still above 2. 6 is above 0.2, and we have created our circuit. So this consists of the power supply, which is here, the LED, which is here, and the load with the two identical resistors. So the LED has lit up, but it is very hard to see as because it is very, very dim. I'll try to show it.
So now with our completed circuit, basically we're going to calculate our voltage
But yeah,
at the
it
load,
is on.
and then our voltage at the resistors, which will give us a voltage drop.
But
Yeah,
it's really weak.
It's really, really weak. But yeah, it's
So
on.
for the voltage, we do our multimeter, and we're going to turn it to voltage DC.
Now we will find the voltage drop across the load. So here shows that we have a total of 2.88 voltage across the load. So that's our voltage. Can you write that down for us? So now we are going to measure our current. So for that we will have to break the circuit. So we'll do like this. Connect this to here. This to that.
Yeah, so what is this one is if we can just measure the voltage
As you can see, it comes to 0.4.
and it follows Ohm's law where V is equal to I times R.
1.4
That's basically
amps.
that's how we verify it.
Let's do this
And
to
then, yeah,
MA.
that's all.
See if this changes anything. No, as you can see, this is the only one that works, and this is the same thing as the other one. Converting it.